We are in your white packet of notes today. Up in a corner somewhere, if you would, please do this warm-up problem. Draw a bearing of 232 degrees. Then from that, find me a trig angle, a reference angle, and then north-south angle from east and west. Again, if when you handed stuff back, if you got some form of a test, it would have been the 5.1, 5.2 test would have been the only ones that I handed back. We're not handing back the other tests until more people are done with them. So check your stuff, what you got handed back, and then give me those back if you do have those. So 232 would be down in here, where this then would be 232 degrees. Okay? Which means then that I need to find the trig angle. The trig angle is going to be this one right here. So I should probably actually find the reference angle first. Reference angle first. So if that's 232 from navigation type things, then that makes this here be 52 degrees, which makes this then be 38 degrees. So my trig angle or my math angle would be 218 degrees. My reference angle is the 38-degree purple angle. And my north-south angle east-west form would be south, because we're going down, obviously, and then we come 52 degrees to the west off of straight south. Questions, comments, concerns, clarifications? All right, let's pick it up then here with vectors in a plane. Okay? So a vector is used to represent quantities that have both magnitude and direction. Come on, work for me. Work for me. There it is. Is this what you were just saying?
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh, yeah!
Oh, yeah! Okay. So a vector is used to represent quantities that have both a magnitude and a direction. What did I do with my notes? Yep. So a vector is, in fact, it's a ray. Okay? So when you draw it on your paper, when you have to draw vectors, which we'll have to draw vectors here in a few minutes, you're going to draw it as a ray, which means that it has a tail. Okay, that That's the start of it. Okay? The tail is where it starts. And it has a head. That's where the arrowhead is. Okay? If you just give me a segment, I don't know which way your vector is going. They have two different vectors that go in opposite directions have different components to that. Just on the side of the head. Yep. Just on the side of the head. Okay. Okay. All right. It is a directed line segment with its tail, or in general, a vector is a directed line segment with its tail at the origin, and its head is then at the point A, comma, B. Okay? But that might not always be the case. We will be later on adding vectors together. And then we won't necessarily have the tail at every single origin. Okay? Vectors, so that vector then can be written in this way. Notice that it looks like a point, but it's not a set of parentheses. Okay? It's a set of like slanted brackets. Okay? If I were to be drawing this one out freehand, it's kind of like, I don't know, half of a diamond. I don't know what to say this symbol is. But then inside, it's just like a point. But it's not a set of parentheses. Okay? It's not a set of parentheses there. Okay? They have that if you smush them together, it'd be a diamond. Okay? This is called the component form of a vector. Okay? So a vector is made up of magnitude and direction. Okay? So vectors can be written like when we write them, sometimes we'll write them in italics, but you don't necessarily have to write them in italics. Another way of writing this, vector V, is V with an arrow over the top of it. Okay? That signifies that you are talking about a vector there. The magnitude would be the length of that vector. The direction of that vector is unit circle directions. Very key. That vectors are unit circle directions. And your names are lowercase letters. Okay? So we can name them with a single lowercase letter, or we can name them with 2 points. So like if I'm going through the points, I don't know, M and P. We can name them with and it always goes, in that case, it always goes, if we're naming it with 2 points, this one is the tail point, this one is the head point. It always goes tail first, then head, if you're going in the 2 point way. Makes a difference. Questions on thus so far? Okay. So we have some vector calculations then that we will be dealing with. The first one is the head minus the tail rule. Any two arrows with the same length and pointing in the same directions represent the same vector. Okay? And so we find that we don't have to worry about finding angles, finding distances, any of that. If we just do the head minus the tail rule, meaning, so vector OP, okay, this one is, by the way, by at the origin. Point O is at the origin. The head minus the tail rule would mean that vector OP is at head 3 minus tail 0, comma, head 4 minus tail 0. Oops, I put a comma there. Means that this is the vector 3, comma 4. Everybody see how I did that? I took the x component of the head and I subtracted off the x component of the tail. I took the y component of the head and subtracted off the y component of the tail. Now, if I do that same thing for S and R, for RS, so R is the tail, S is the head, so I would go -1 minus -4. And then I'd go 6 minus 2. -1 minus -4. 3. 6 minus 2. So those two, vector OP and vector RS, are equal or the same vector, because they have the same vector components, head minus tail. Okay? If P and Q are there, show that that is the same as vector RS. So vector RS, once again, was the vector 3, 4. Okay? You show me that PQ is an equivalent vector to them. Five minus 2 and 3 minus -1 gets me PQ is the vector 3, 4. So those two then are now equivalent. Agree? Okay? Love it. So let's do some other operations of vectors. So first off, let's graph vector v. Okay? So vector v is the vector -2, 5. So that gives me a horizontal component of -2, which would be 2 to the left. That gives me a vertical component of 5. 1, 2, 3, 4, and 5 puts me right there. So vector v is right there. Okay? So we draw it from the origin, where its tail is, and the head then is at the point -2, 5. Okay? The opposite of V. Okay? Well, this V has a direction, right? And it has a magnitude. That's a specific length. So the opposite of V would be, would the length change of vector V? No, what's the only thing that's changing? The direction is changing. So instead of the vector going up and to the left, the vector is going to now go down and to the right. 1, 2, 1, 2, 3, 4, and 5. There is my point that I want to get to. 1, 2, 3, 4, 5. Right there. So it's going to be vector opposite of V is going to equal +2, -5. It doesn't just flip around where it's at because the direction has changed. The direction is going in the opposite way. Okay? So it needs to go down and right. Suppose we have vector u, which was our vector -2, or excuse me. So we okay. 2, 1, 2, 3, 4, 5. So there is u. We called it v in the last one, but now we're calling it u. Okay? And then we have vector v, which is the 3, -2. Okay? There's a couple of different ways that you can go about doing this. Okay? First off, you can put one vector in. And it's kind of a head to tail rule, where so the first vector that you put in, that gives you a tail, then a head. Then from that, you connect a tail, 1, 2, 3, 1, 2, to it. Tails get connected with other heads. Okay? And so then that would be your resulting vector. So this was vector v, and so then this is vector u plus v. Now, if we do this, if we figure out pointages here, this point would be at the point -2, 5. This point would be 3 to the right, and 2 down from it, which means it would be at 1, 3. So vector u plus v in component form would be 1, 3. That's by going through and doing it off of the graph. Everybody with me so far? Now, you're all smart. You've got something in betwixt your ears. Is there an easier way to get the component form 1, 3 from vector u and vector v? What do you got, Nadia? So take the horizontal components, okay, and add them. Same thing with the vertical component. Yep, exactly. So we could have just taken the horizontal components and gone -2 plus 3. And taken the, nope, I used green already. I used pretty much all the colors. And taken 5 plus -2. And gotten the same thing. Okay. Still another way, this is like kind of an old school way. I'm just going to show it to you. I don't ever expect you to do it this way because this is the long way. This is going to Mosinee by going through Marathon and coming back down and up. Okay? You can take this vector and you can put it back here. And then you have two sides of a parallelogram. And then you make the parallelogram there's the parallelogram. And it's the missing vertex in the parallelogram. I don't like it. Not a fan of it. That's old, super old school way. Much easier to do it either graphing head and tail to head or just simply adding. Okay? Yet another way, or another vector calculation that we can do. Okay? Scalar multiplication. So vector v is the vector 3, gamma, -2. So there's my vector v. What does 3 v's mean? So I would put like another one in there. Oops, yep, breaks. We got 2. Now, will it let me? Oh, it did. There it was. So you're saying like this, Joey? And then like this? So then we have another V and another V, right? So all told, if I've got 3 V's, then that puts me down here at this point, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. At the point 9 comma -6, which would make my 3v vector that. Okay. Quicker way. Multiply by 3. Okay. Scalar multiplying distributed property almost, if you will. Okay. Just straight up multiplying by 3. Okay. Just straight up multiplying by 3. vector subtraction. Okay. So if we have vector u, that's my 3, 4, and 5. There's vector u. There's vector v. How are we going to do subtraction? What do you mean? So you're saying u minus v is going to be u plus the opposite of v? We all agree with that? Okay, all right. So the opposite of v then would be, so I would go, instead of right 3, I'd go left 3. Instead of down 2, I would go up 2. Oops, wrong color. So we would be at this point right here then, which would be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Agree with that? Okay. Short way. Horizontal minus horizontal. And vertical minus vertical. Okay. So there's really no, up to this point in time, there's really no tricks to vectors at all. Other than you're going to want to, trust me, I've seen it 1,000 times, other than you're going to want to put parentheses instead of the funky brackets. Okay? That's really the only trick going on right now. Agree? Fantastic. With that being said, I would like you to do number 5 here. U is -1, 3. V is 2, -5. R is 2, T is -3. Find me those 5 different vectors. Go. All right, so U plus V is going to be -1 plus 2 and 3 plus -5. So that means that U plus V is going to be 1, -2. Agree? Okay. Should there. U minus V is going to be -1 minus 2 and 3 minus -5. That's going to be -3, 8. T times U is going to be -3 times u. So that's going to be -3 times -1 and -3 times 3. So that's going to be 3 comma -9. RV is going to be twice V. So that's going to be 4 comma -10 plus TU is going to be 3 comma -9. 4 plus 3 then is 7. -10 plus -9 is -19. Agree with me on that one. Then we had letter E. -R times U is going to be -2 times -1, -2 times 3, that's going to give me 2 and -6. That's a bad one. Yes? Love it. All right. Magnitude. Magnitude, which is also the length of a vector, which has a special symbol. Okay? So the magnitude is the length, and it's got a double absolute value for a symbol. Okay? That is the symbol for magnitude. Double it up. Okay? So if your vector V is x comma y, because it's in the standard position, typically, okay, meaning origin is the tail, x comma y is the point at the head, okay, then the magnitude of V is going to be the square root of x squared plus y squared. Okay? Because it's Pythagorean theorem. So the magnitude of W, then, in this case, would be the square root of -2 squared plus 3 squared. -2 squared is 4. 3 squared is 9. 4 plus 9 is 13. So the magnitude of W is the square root of 13. The direction angle of a vector is once again our trig angle. Or our math angle, if you will. So again, if vector V is at the point x comma y, then we're going off of reference angles. which we did first semester when we were dealing with finding angles on the unit circle. So that refresher was, remember that we have theta prime is equal to the inverse tangent of y divided by x, where the big thing is we drop any negative signs in x or y. That's going to find you the acute reference angle, and then depending upon which quadrant you are in, if you are in quadrant number 1, actual theta is your reference angle. If you're in quadrant number 2, actual theta is 180 degrees minus your reference angle. If you're in quadrant number 3, actual theta is 180 degrees plus your reference angle. And if you're in quadrant 4, actual theta is 360 degrees minus your reference angle. So if vector W was once again the vector negative 2, 3, bless you twice, whoever sees, and then my reference angle, theta prime, is going to be the inverse tangent of 3/2, because I drop, I drop the negative sign. Somebody with a calculator, inverse tangent of 3/2. Okay. Which quadrant is the vector negative 2, 3 in? In quadrant 2, left and up. That's quadrant 2. So because I am in quadrant number 2, that means my actual theta is going to be 180 degrees minus my reference angle of 56.31 degrees, which is going to give me a direction angle of W, and that's how we write the direction, because we're going to have multiple vectors going on here. So theta with a subscript of what vector it is. So the direction of W then would be 123.69 degrees. Questions, comments, concerns, clarifications? You find me the magnitude of U and the direction of U. I get a magnitude of 2. Positive and negative is quadrant number 4. So that would give me a direction angle of U of 300 degrees. Agree? Working backwards now, if you're given the length of your vector and you're given the direction angle of your vector, trigonometry tells me that if there's my vector, here's my angle, that then this would be, so this would be the magnitude. That if I need to solve for this side, that's going to be the sine. So it's going to be x there is going to equal the magnitude times the sine of my angle. If I need to solve, oops, I should have put x down on the bottom. Capital L breaks. Come on, Lindsay. Think ahead. And x would be cosine based off of SOHCAHTOA. So in general, vector v is going to be the magnitude of v times the cosine of the direction of v, comma, the magnitude of v times the sine of the direction of v. So in this particular case, it would be 6 cosine of 135 degrees, 6 sine of 135 degrees. Now, because 135 is on our unit circle, we expect it to be exact. Unit circles, exact. Non-unit circles, you can round. Okay? So the cosine at 135 is negative root 2 over 2. The sine is the square root of 2 over 2. So vector v here then would be negative 3 square roots of 2, comma, 3 square roots of 2. And because it's on the unit circle, we leave it in exact form. Okay? Good stuff. In terms of your, what color packet did we go with this week? Salmon. In terms of the salmon packet, you can do, or you can start the 6.1a worksheet. You should be able to right now be able to do for sure the front side and a lot of the second side. Okay? So you can do that 6.1a worksheet anytime now. Still working along to on the 20th of this month being your navigations and vectors test.